Hey guys, good to see you. Although I can't see you, it's still good to pretend to see you. I missed you guys. Anyway, today we're going to talk about section 7.2, which is dealing with systems of equations. 7.1, which was due Monday night, dealt with solving a system of two equations, either using elimination or substitution. Today, we're talking about solving three equations, three variables. Really requires you to keep orderly notes, keep your work nice and clean, because there's a lot to keep track of. So I have one example on the board here. You can see we have three equations, right? We have three variables, x, y, and z. First thing I do, and this is what I recommend, is I number them. So I'm going to call this equation 1, that equation 2, that equation 3. It's the first thing you're going to want to do. So now, the idea of what we're doing here is this. We want to, basically, we're going to take two pairs of equations. We're going to take these three equations and break it up into two pairs. And in each of those pairs, we're going to eliminate the same variable. The idea is, out of both pairs, like you're going to cancel x's in both of them. That way you're only left with y and z, or x and y, or x and z. So that then you only have two equations, two variables. We know how to do that. So some of these will be easier to do, some of those will be harder to do. So in looking at this one, what I would try to do is say, okay, you can either look and see, okay, which equation would be easy, or which variable would be easiest to cancel out, or you could think, just pick a variable and go with it. Here, when I look at this, I see negative 5y's and positive 5y. So I think I could really easily cancel out the y's there. So that's what I'm going to do. So notice these both have negative 5y's. This has a positive 5y. So what I'm going to do is I'm going to pair each of these with the 5y. So I'm going to start by pairing equation 1 and 3. So that's negative x minus 5y minus 5z equals 2. And x plus 5y minus z equals negative 20. Now I picked those because notice if I add them together, these y's are going to cancel each other out. And that's very convenient. Sometimes you may have to multiply one or both of those in order to make that happen. And that's okay. It's just a matter of picking one to do. So I'm just going to add them together. So here if I add negative x and x, it just so happens that those cancel. And that's okay. Negative 5y plus 5y also cancels. Yay. Negative 5z plus negative z would be negative 6z. 2 plus negative 20 would be negative 18. So in solving that here, I could actually solve for z. Divide both sides by negative 6. And I find out that my z term is 3. There's one of our variables. Usually that won't happen. Usually, like I would cancel the y's out and I'd be left with an equation with x and z in it, or something like that. All right, so I canceled out the y's there. That was my goal. I'm going to do that again. So now instead of pairing 1 and 3, I'm going to pair 1 and 2 together. So 1 is, so again, 1 and 2. So we have negative x minus 5y minus 5z equals 2. Equation 1, and then equation 2, we have 4x minus 5y plus 4z equals 19. So notice here, I could cancel out the y's. I just need one of them to be negative. So a really easy way to do that, multiply one of them by negative 1. Maybe the top one. So negative 1 times negative x would be a positive x. Negative 1 times negative 5y would be a positive 5y. Negative 1 times negative 5z is a positive 5z. Negative 1 times 2 is negative 2. Add them together. 4x plus x would be 5x. Negative 5y plus 5y cancels. Again, that was the goal. 4z plus 5z is 9z. 19 and negative 2 is 17. So that would be another equation. Normally then I would use that in this equation to cancel out either x or z. But in this case, I already know what z equals. So I can take that and plug it in here and solve for x. So I know z is 3. So I can say 5x plus 9 times z, which we found is 3, equals 17. Solve for x. So 5x, 9 times 3 is 27. So to solve for x, since it's plus 27, we would subtract 27 from both sides. So you get 5x equals negative 10. And then divide by 5. And you find out that x is negative 2. So now we know what x is, we know what z is. And so now I can take those and plug it back into any of these equations to find out what y is. It doesn't matter which one. So maybe let's just throw in the top one. What the heck? So I'll use this space here. So if I put it in the first one, we get the negative of x, which is the negative of negative 2, minus 5y, minus 5 times z, which is 3. I'm going to erase that for space here. Equals 2. See, the negative of negative 2 would be positive 2, minus 5y. Negative 5 times 3 is negative 15, equals 2. If I combine like terms here, negative 5y, 2 minus 15 is negative 13. Add 13 to both sides. You get negative 5y equals 15. Divide by negative 5. And you find out that y is negative 3. So now we have all three answers, right? Here we found z is 3. So our answer, and you'd actually be put it in order, x, y, z. X was negative 2. Y we just found out is negative 3. Z we found out is positive 3. And that would be your answer. Again, it's nice when you have a little bit more space than what I have here, but that's the main idea. So again, you want to take two pairs of those three equations, break it into two pairs and eliminate the same letter from both pairs. And that should leave you either with a way to solve it like this, or then you'll have two equations with two variables that you can solve. So why don't we try another one? All right, here we have another system of equations. So again, we want to break this down into two pairs of equations, and we're going to cancel the same thing out of both of them. So looking at this, I think, again, I'll try to eliminate the y's. So again, if I number them, 1, 2, and 3, again, if I pair negative 5y with a positive 5y, those are easy to do. So let's start with doing 1 and 3. So equation 1, we have negative x minus 5y plus z equals 17. Equation 3, we have 2x plus 5y minus 3z equals negative 10. Notice because of the negative 5y and positive 5y, I don't have to do anything to it to cancel. That's really nice. I can just add them together. So those cancel. Negative x plus 2x would just be x. Z plus negative 3z is negative 2z. 17 plus negative 10 is 7. Okay. So there's one equation that just has x and z in it. Now we'll do the same thing, taking a different pair than 1 and 3 and canceling y again. So let's say this time I do 2 and 3. Right? In fact, I'll just do it right here. With 2 and 3, again, the y's are going to cancel out there. So if I add negative 5x plus 2x, we get negative 3x. 5z and negative 3z is 2z. 5 minus 10 is negative 5. I'll call this equation 4, this equation 5. So now we have those two equations with only x and z. So now we can do what we did in 7.1 and solve by substitution or elimination. So I'm going to bring this over and write it underneath the other one. So negative 3x plus 2z equals negative 5. Now this is where you'd either multiply one or both by something, or in this case, they actually, if you just add them, the z's will cancel. It won't always be quite that easy, but. So if I were to go ahead and add those together, x plus negative 3x would be negative 2x. 2z plus negative 2z plus 2z is 0. 7 plus negative 5 is 2. And then solve. Negative 2 times x. So we'll do the opposite and divide by negative 2. And we find out that our x coordinate is negative 1. So there's x. So we have negative 1 and then something and something. Now that we have that for x, I can plug that back into equation 4 or 5 and solve for z. So let's go ahead and, why don't we plug it into equation 5 here. So we'd have negative 3 times x plus 2z equals negative 5. And again, it doesn't matter which one you plug it into. You're going to get the same answer either way. So it doesn't matter. It's just pick whichever one you want, whichever one looks better, whichever one your mom likes, whatever. It doesn't matter. So here, negative 3 times negative 1, if we work that out, that gives us a positive 3. Solve. So to solve, we've got to move that 3 over. So I would subtract 3 from both sides. So 2z equals negative 8. And then divide both sides by 2. And you get your z coordinate, which is negative 4. So we know x, we know z. We need to find y. So now I can take that x and that z and plug it into any of those original equations. Doesn't matter which one. You'll get the exact same answer regardless of which one you pick. So, I don't know. Let's go with equation 3. Sounds like fun. So 2 times x. Well, we found out that x is negative 1. Plus 5 times y. Minus 3 times z, which we just found is negative 4. That equals negative 10. Again, I chose equation 3. You could use equation 2, equation 1. Doesn't matter. You get the same answer out of all of them. So just pick one. So 2 times negative 1 would be negative 2. Plus 5y. Negative 3 times negative 4. Negative times negative would be positive 12. Equals negative. All right, guys, last example we're going to look at. So these, instead of x, y, and z, we have a, b, and c. Doesn't really matter what the letters are. So again, I would start by numbering them. So I'm going to number them 1, 2, and 3. So again, what we're going to try to do is pair them up and eliminate the same, make 2 pairs and eliminate the same variable out of each of them. In this one, I don't see any really great easy pairing other than if I add these 2, the a's cancel out. So maybe I'll start with that and then I'll have to pick another pair and cancel the a's again. So I'm going to start by just adding 2 and 3 together. We'll add these 2. So if I do that, 4a minus 4a is 0. 3b plus 3b, 6b. 3c plus 3c is 6c, like me. Negative 6 plus 9 is 3. So there's, I'll call that equation 4. So I need to get rid of a again. I think I'm going to do 1 and 3. I'm just going to do it right underneath here. So if I take 1 and 3, that is 5a plus 5b plus 5c equals negative 20. 3 is negative 4a plus 3b plus 3c equals 9. So again, I'm wanting to get rid of a. So in this case, I can't just add them together. It's not going to work. So I have to think of what could I make both 5 and negative 4 into so that they would cancel out. Well, I can make them both into 20s. One's already positive, one's already negative, so that's good. So what I would need to do here to make that into a positive 20, I would have to multiply by 4. Here, to make it a negative 20, I'd have to multiply by 5. So if I do that, 4 times 5a is 20a. 4 times 5b is 20b. 4 times 5c is 20c equals 4 times negative 20 would be negative 80. If I multiply the bottom, 5 times negative 4a would be negative 20a. 5 times 3b is 15b. 5 times 3c is 15c. 5 times 9 is 45. Right? So again, doing it so that these two are the same, so that now if I were to add those two together, notice 20a and negative 20a, those would cancel. 20b plus 15b is 35b. 20c plus 15c is 35c. Negative 180 and 45 would be negative 35. These are kind of ugly numbers. So I'll call that equation 5. So if I put these two equations together, I'm going to do that up here. We got equation 4, which is 6b plus 6c equals 3. Equation 5, this is 35b plus 35c equals negative 35. All right, so now we need to eliminate either b or c. So I need to make either b, the b's into the same number but different signs, or the c's. Now in this case, they are both the same. So let's see. So let's say I want to get rid of the b's. Right? Now, what is 6 and 35 both going to? I'm not sure, so I'm just going to multiply them by each other. So I'm going to multiply this one by 35 and this one by negative 6. That way their signs are backwards. So 35 times 6 would be 210b. 35 times 6c is 210c. 35 times 3 is 105. On the bottom, negative 6 times 35b, negative 210b. Negative 6 times 35c would be negative 210c. Negative 6 times negative 35 would be positive 210. So again, my goal there was to get the b's to be the same but opposite signs. Now this is one of those weird cases. Notice now if I were to add these together, 210 minus 210 means no b's. 210 minus 210 means no c's, so I get big old fat 0 over here. 105 plus 210 would be 315. Does 0 equal 315? I don't think so. If it does, if 0 is 315, I got a whole lot more money in my bank account than I thought. No, that doesn't equal that. So this would be the case where you'd either write no solution, or most books will say no unique solution, which means they don't only cross in one place. The three lines, they either don't cross at all, or maybe they cross in multiple places. So yeah, that would be no solution. So again, the idea with all of these Take your 3 equations, break them into 2 pairs of equations, and out of those 2 pairs, eliminate the same variable. Get rid of the x's from both of them. Get rid of the y's, get rid of the z's, get rid of the a's, whatever. Eliminate the same variable. So then you have 2 equations with 2 variables. Then solve those the way you did in 7-1 using either substitution or elimination. So I hope this helps. I hope this helps make sense. I miss seeing you guys. Just so you know, for the college semester, for those of you who are taking dual enrollment, the college semester ends the end of next week. So that's why you have your Unit 7 test end of next week. And then that's the cutoff for the college, which then I'll have to submit those grades for those. But the high school class will still go on for a few more weeks here. So anyway, I hope you guys are doing well. If you need help, email me or come see me on Google Hangouts for math analysis. That would be Tuesdays and Thursdays at 3 o'clock. So take it easy, guys. Deuces.
12 minutes left.
Okay, my mouth and lips are so dry.
All right, is that a wrap?
That's a wrap.